An internal combustion engine is a marvel of engineering, a complex assembly of moving parts working in violent harmony to propel you down the road. But this power does not come from hope or magic. It comes from a network of support systems that work tirelessly, often out of sight and out of mind. You might never see them, tucked away beneath plastic covers behind belts and deep within the engine block itself. Yet, each one is absolutely critical to keeping your engine alive and performing as it should. This essay will pull back the curtain on 5 of these secret systems: the lubrication system, the cooling system, the filtration system, the intake system, the exhaust system. When one begins to falter, the others feel the strain, leading to a cascade of problems that can hurt performance, reduce fuel economy, and ultimately lead to expensive repairs if ignored. Understanding these systems is not just for mechanics. It is for every driver who wants to get the most out of their vehicle and avoid preventable breakdowns. You do not need a degree in engineering to grasp the fundamentals. By learning what each system does, how it can fail, and what simple checks you can perform at home, you empower yourself to become a more informed and proactive car owner. This knowledge transforms confusing symptoms like strange noises or warning lights into understandable signals that your car is sending you. We will use cause and effect charts, described in plain language, to visualize how a small issue in one area can snowball into a major problem affecting the entire engine. The lubrication system is arguably the single most important system for an engine's survival, acting as its essential lifeblood. Its primary job is to circulate engine oil to all the moving parts, creating a thin, protective film between metal surfaces. This film of oil is crucial because it dramatically reduces friction, which is the enemy of any machine. In addition to reducing friction, the oil also plays a vital secondary role in cooling, carrying heat away from the hottest parts of the engine, like the underside of the pistons, and transporting it back to the oil pan. It also helps to clean the engine by picking up tiny metal particles, combustion byproducts, carrying them to the filter. The system itself is a closed loop. It begins with the oil pan at the bottom of the engine. An oil pump draws oil from the pan through a pickup tube. This pressurized oil is then forced through an oil filter, which is designed to trap dirt, sludge, metal shavings. From the filter, the clean pressurized oil travels through oil galleries to the main bearings, connecting rod bearings, camshaft bearings, valve train, before the oil eventually drips back down into the pan to repeat its journey. The most common cause of failure is neglecting to change the oil and filter. Over time, oil breaks down from heat and contamination. It becomes thick with sludge, thin and watery, providing poor protection. Another critical issue is a low oil level, often caused by leaks or consumption. Start with low or dirty oil. Friction rises, excess heat, accelerated wear, even a seized engine. While the lubrication system fights friction, the cooling system battles an equally formidable foe: heat. The process of internal combustion generates an incredible amount of thermal energy. Only a fraction is converted into useful power. The rest must be managed and removed, or components would warp, melt, and fail. The cooling system is the engine's dedicated temperature regulator, circulating coolant, antifreeze, through passages. At its heart is the water pump. Hot coolant flows to the radiator. Airflow and fans pull heat. Fluid returns to repeat the cycle. A small but critical thermostat acts as a flow valve to help the engine warm up and maintain ideal temperature. Leaks or a failing pump reduce circulation. A stuck thermostat can prevent warm-up or cause overheating. Our cause-effect chart shows the chain reaction from low coolant to catastrophic failure. Spotting signs early prevents disaster. Hot gauge, steam, a sweet antifreeze smell, or a heater blowing cold. At home, check the translucent reservoir between min and max. Look for colored puddles. Inspect hoses for cracks, bulges, or softness. Every engine needs a steady supply of clean air, clean fuel, clean oil. The filtration system is the network of unsung gatekeepers. It's not one part, but 3 filters. The air filter sits at the intake and traps dust, pollen, insects, and other airborne debris. The fuel filter sits in the fuel line, screening out rust, dirt, and other particles. The oil filter is part of lubrication, removing metal shavings and sludge. Filters protect cylinders, rings, and precision injector nozzles. Neglect leads to poor spray and misfires. Visual: cause, clogged air, fuel, or oil filter. Effect: restricted flow. Outcome: reduced power, lower fuel economy, and higher wear. A clogged air filter chokes the engine. A clogged fuel filter starves it. A clogged oil filter can force bypass, letting unfiltered oil circulate. Signs include sluggish acceleration and decreased fuel economy. Check the air filter. If no light passes, replace it. Fuel filters can be involved. Consider a mechanic. Replace the oil filter at every oil change. If the air filter is the set of lungs, the intake system is the entire respiratory tract, guiding a precise amount of clean air into the cylinders, providing the oxygen necessary for combustion. The throttle body valve opens and closes as you press the accelerator, controlling engine speed and power. After the throttle, the intake manifold distributes air evenly to each cylinder. Sensors measure airflow, temperature, pressure, and feed that data to the engine's computer. The ECU calculates fuel for an optimal mixture. Too much air, lean, causes high temperatures and misfires. Too little air, rich, wastes fuel, creates emissions, and can foul plugs. Some engines add forced induction, turbochargers and superchargers to force extra air and boost power. Intake design: runner length and tubing smoothness. Maximizes airflow and efficiency. Cause: air leak or faulty sensor. Effect: incorrect mixture and inefficient combustion. Result: low power, poor fuel economy, high emissions. Unmetered air after the MAF leans the mix, causing rough idle, hesitation, and stalling. A dirty or failed MAF can mislead the ECU and skew fueling. Diagnose by listening and looking. Scan for codes. Clean a MAF if you're confident. Bigger issues need a pro. Just as an engine must breathe in, it must also breathe out. The exhaust system removes hot, noxious gases, quiets combustion, and reduces pollutants. It begins at the manifold, then through a downpipe into the catalytic converter, onward to mufflers, and out the tailpipe. Catalysts in a honeycomb convert carbon monoxide, nitrogen oxides, and unburned hydrocarbons into carbon dioxide, nitrogen, and water. The muffler's chambers cancel sound waves, reducing roar to a hum. Restrictions create high back pressure, like trying to exhale through a straw, choking the engine. Common causes include a failed catalytic converter or a rusted, collapsed muffler. Blocked exhaust raises back pressure, cuts power and fuel economy, and can even cause overheating. Listen for roaring, rattles, and note a sulfur smell. Sudden loss of power or inability to rev suggests blockage. Inspect when cold, then listen running. If you suspect the catalyst, see a mechanic immediately. No single system operates in a vacuum. They are interconnected, a mechanical symphony. If one is out of tune, the performance suffers. A cooling failure overheats the engine, breaking down oil, thinning viscosity, reducing protection, accelerating wear, a vicious cycle. A neglected air filter restricts airflow, enriches mixture, causes carbon buildup, and can overheat the catalytic converter. Symptoms may not point to the root cause. Take a holistic approach. Charts reveal relationships. Power drops as airflow drops. Oil thins dangerously as temperature rises. Exhaust flow plummets as back pressure increases. An engine is a system of balances. When one element is thrown out, efficiency falls, performance drops, and component stress rises. Your role as the conductor: home checks and maintenance. Proactive maintenance saves money, ensures reliability, and extends your vehicle's life. Catastrophic failures are often the result of small, ignored problems. Know what's normal, its sounds, its smells, its performance, so you can spot changes quickly. Monthly, with the engine cool on level ground, check oil level and condition, and the coolant reservoir between min and max. Annually, or sooner in dusty conditions, inspect the engine air filter. Most use simple clips. Visually inspect belts and hoses for cracks, fraying, and bulging. Watch gauges. If the red oil pressure or high temperature light appears, pull over and shut off immediately. Address new noises. Do simple tasks at home, but see a pro for major leaks, overheating, or a flashing check engine light. We have journeyed through the hidden world beneath your hood. Lubrication, cooling, filtration, intake, exhaust. Each performs an essential function, and together they must operate in harmony. The signs of trouble are there: the unusual noise, the strange smell, the warning light, the small puddle. With simple checks of oil, coolant and filters, and attention to changes, you can catch problems early and avoid large repair bills. Follow the service schedule. If a symptom appears, act. Don't just turn up the radio. Be the diligent guardian of these systems, and your engine will remain healthy, efficient, and reliable for every journey ahead.